Do I need the clicker? Yeah. Hi, everyone. It's great to be here this afternoon. I'm a security guy for like 20 years now, but I love getting outside of the security conference bubble and talking to the people actually building stuff, the people making stuff, the developers, because I feel you are the ones who can make the biggest difference to preventing security problems in the first place. So what I'm going to talk about today is open source components, and everyone is using open source components. It's great, right? It makes us go faster. We can build things quicker, probably build things more reliably, but you have to manage the risk that's in those open source components, and it's becoming a bigger and bigger problem. So I want to talk to you about that today. So if you look at a modern application, really what you're looking at is something that's 80 to 95% open source components. It wasn't this way, 20 years ago. That's when open source components just sort of started, right? But it's accelerating rapidly. And there's all kinds of places, repositories, where developers are getting code. And the newer your code, like if you start a project today, it's more likely that there's more open source in there. If you look at the trend here, I have on this diagram, I have both Java from the Maven repository and JavaScript coming from NPM. You can see that just in 2016, there was 52 billion downloads of Java packages and 59 billion downloads of JavaScript. So JavaScript last year actually came out of nowhere in the last 3 years and surpassed Java. So every developer, no matter what language you're using, is using a huge amount of these components. And you're not just downloading the components, there's new components every day. So there's over 1,000 new projects across both NPM, Java, NuGet, PyPy. The biggest repositories, there's over 1,000 new projects being built every day, brand new projects that someone's building and putting out there. And then if you look across all of the open source components out there, there's 10,000 new versions a day. So people are updating, they're fixing bugs, they're adding new features, and they're probably even fixing security vulnerabilities that have been discovered and are now known. And that's really what I want to talk about. The other place that open source is coming from isn't just downloading from one of these package repositories. People are using Docker containers. They're downloading things from Docker Hub. That container is full of open source components in there that your applications will be linking to and calling into. So this is another source where they're coming from. This is a little bit of a shadow source. A lot of people don't think about what's coming in their container. Even if Docker is scanning the code and they're saying, hey, there's no known vulnerabilities that we know of when you download that, we have to think about how does that change into the future. Vulnerabilities get discovered, and we have a saying in the software business, software security business, that software rots over time. Right? Over time, it gets riskier as new vulnerabilities are discovered in something that you've already used. So when I look at like open source, people always ask me, what isn't open source more secure? Eric Raymond famously said, lots of eyes make all bugs shallow. Frankly, there's just not enough eyes to go around. With 1,000 new packages a day, 10,000 new revisions a day, there's no army looking at all of that code. So it's going to be project by project, how much that project cares about security and code reviewing themselves, and the users of that project, how much they care about looking at the security. So there's really a range that you can expect of risk when you're using an open source package, just like there is in commercial software. Some companies do a better job than other companies. But the difference between open source and a lot of commercial packages is, or your own proprietary code more really, is that there's a sort of this integrate it and abandon mentality. I got the library, I installed it, it works, my functionality is there, and I'm happy. And I'm going to go on and build my UI, my business logic, and all that. The functionality of the package works. And maybe if I run into a bug or I want a new feature, I'll think about updating that package. Well, what I'm here to tell you is you really have to look and monitor if you're using that package, what new known vulnerabilities come about. Because when a vulnerability becomes known, it means the attackers know it too. And the attackers can race you to trying to exploit that vulnerability. They can watch the security updates, find that vulnerability, and then start to scour the internet for that problem. So this is generally the sizing of the problem we see. 96% of applications contain some open source components. On average, it's 46 components, so it's a pretty big number, and that's on average. And when we look at those, the vulnerabilities coming from those components, 67% of the applications we looked at had one or more vulnerabilities coming from an open source component. The last statistic here is kind of the scariest one. When we found a vulnerability in an application we inspected, and it was from an open source component, the average age of that component was 4 years. So the vulnerability had been sitting there dormant for 4 years. So just a couple of examples to talk about the real world. Struts, very popular package for Java applications, was really popular, more 5 years ago or so. But there's a lot of applications that use it that are still around. And if you look at my chart here, the purple or the sort of the reddish color there are the vulnerable versions of that software. So these are all the different versions that we saw our customers using across all the applications. And if you look at the reddish purple there, that's actually the majority of the versions people are using. And when we inspected, had the vulnerability. So Struts has had some struggles over the last few years with some really serious vulnerabilities. Most notably, the Equifax breach back in March was due to a Struts vulnerability that Equifax didn't monitor their open source usage properly, did not update their software, and we all know what happened. It's one of the largest data breaches of all time, 180 million plus records. It's probably going to cost them over $100 million in liability. Another package that's quite popular in Java is Apache Commons. And this is a very fundamental library. It's got very basic operations in it. You can think of it as sort of the standard library in C if you're a C programmer. And if you look at my chart here, the red there are the vulnerable versions, and those are the most common versions. When we looked across all the ones that people were using, the vulnerable ones was actually the most common ones. An example of an attack, it hasn't been verified, but I've heard several people that sort of have inside knowledge that the SF Muni Attack, which took down the San Francisco subway system's ticket vending machines, and they had to put out free rides for a few days, was due to attack on this vulnerability, which is a remote code execution vulnerability. So just to look at sort of the scale of the problem here, packages rely on other packages, rely on other packages. We all know about dependencies. If you look at the Apache Commons collection, and you look at, because it's a very fundamental component, how many packages are ultimately affected, it actually comes out to 80,000 packages. We went 5 generations deep looking at all the usages across Maven. And that means that those 80,000 plus libraries are used in millions of applications. So you can see how one vulnerability, you think of it in one little package there, we're now getting to a point where a vulnerability of this class, like Apache Commons, gets to the scale of a vulnerability in something like Linux or Windows. It's affecting millions of systems. So you can see how attackers would really want to go after this kind of thing. And we saw that 26% of all applications, Java applications we looked at, had this. So the other thing to think about is, yes, there's vulnerabilities. Programmers make errors. We need to do that. But there's been a trend now with malicious packages where people are typo squatting on packages, removing a hyphen, changing a letter, and you could be downloading a bad package. So that's just something else you want to be wary of. So I just want to finish up here trying to say, well, what's the solution to this? The solution to this is you have to start to think about this like manufacturing. Like if you're a car manufacturer, you're tracking where every part comes from. So if that part has known defects in it, you can do a recall on all the cars that use that part. This is the kind of mentality, manufacturing mentality we have to start to use because this is our supply chain, right? The open source components are our supply chain. We have to monitor if something has gone wrong with that component and take action on it. So keep track of what you have. Is my best advice. There's some open source and commercial products that can help you do that. So that's all I have today, and I'm going to turn it over to Window here now. Thank you.
Thanks a lot.
I don't have slides, so you can keep that.
You don't need that, right? OK.
Thanks, Chris. So I met my co-panelist here, Chris Wysopal, when I was a teenager. We were connected through a group of Boston computer security enthusiasts in the mid-90s. And there were pockets of such people around the world, but there were not that many of us altogether. Back then, we had to build our own tools and figure out things for ourselves because there wasn't much information available in this space, the security space. It was kind of specialized knowledge. And when people figured out something new, like how to exploit memory corruption mistakes in code and use that to change flow control on a system, if they shared it, which is a big if, you could take that information and build on it, which is fantastic. And the first time someone demonstrated this, it was a Stack Overflow. And that was shared as an exploit, which was just a very small piece of code. And then someone wrote a text file explaining how to do it. And then eventually get more vulnerabilities demonstrating this concept, and eventually talks at hacker conferences. And the industry grew up. And now we have security conferences and tech press who write about security issues. We've got books. We didn't have books then, not on these topics. You've got classes at universities. You've got graduate programs at universities. We've got academic papers instead of T-files. And we've got industry analysts and cyber warfare and laws and regulations and treaties. And security experts on the news describing how a security vulnerability can compromise your car. It's a $90 billion industry this year, according to Gartner. And some of the stuff out there is valuable in terms of those tools and services that make up this $90 billion industry. And some of it is snake oil. And the people who are tasked with purchasing it are not always equipped to evaluate which is which. It's hard to measure the efficacy of a lot of these security solutions. Because for the most part, these solutions know how to find the things that they know how to find, but it might not necessarily be the things that you need them to find. It might not be the things that are real threats to your system or your organization or your code base. And it's just difficult. But this is a talk for developers, because you're developers. And many of the tools that are available to you are easier to evaluate and measure, and a lot of them are free, most of them even. And you can get a lot farther using the concepts we've known about for decades, since we began in this space, than trying to tune security analysis software to your specific code base. Even though we've known for a very long time what to do, it's still not done consistently in a lot of places. For a development environment at a startup, it's easy to trade off long-term strategic choices of all sorts, not just about security, for getting features shipped. For more mature organizations, it's easy to think your code is not likely to be targeted, or that attackers will go after different weaknesses in your environment and not make an investment in security until the organization feels pain. There's a compromise, or maybe it's a competitor with similar technology that's compromised, and you realize, wow, that could have been us. And now you find yourself backing into security thinking with a pile of legacy code. And maybe you've identified lots of vulnerabilities, and you've got a huge backlog. Maybe you haven't found any because no one on your team is equipped to go looking for them. No matter where you're starting from, you can do things to dramatically reduce the vulnerability in your code base, or at least the impact of compromise on your code. You can make it harder, more expensive for an attacker to go after whatever it is that's valuable in your environment. So identify your assets. Is your app collecting personal information? Does it perform financial transactions? Is your system sending communications? Is your code installed on a system or device that's valuable? Is it running on a site with any users at all? An attacker might want to go after the data you store or transmitting across the network, capture credentials or transaction information, or even use your app to compromise your user's device as a first stepping stone or an entry point into their systems. Vulnerabilities in your web app can be used to compromise your servers to allow an attacker to host exploit kits that take advantage of security issues in browsers in order to compromise the data on your users' machines. Even your little game app has value to an attacker. Your web app has value. Attackers are opportunistic, and they can make all sorts of problems. They can make use of all sorts of problems that you might consider beneath their notice. So let's think about defense in depth. This is some of the most basic place to start. Some of your mitigations will be defeated, maybe all of them. So don't you put your faith in any single point of failure. Your WAF is not going to catch everything. Those consultants you hired to identify vulnerabilities in your code, they didn't find everything. Besides, it's been 9 months since they were here, and you've introduced how much new code? That tool you installed triggered on something, but it's been sending so many red flags, and no one's watching anymore. Defense in depth requires compromising multiple assets before getting to your assets, so that you're not a single step away from complete compromise. Building security through all aspects of the development process. This is probably the most important thing that you can do, and that starts at security training. Now, whether that's evaluating information that's out there, incorporating that into your development environment, you can do this at 5 people, you can do this at 10 people. But going out there and educating yourself on the security basics that impact your platform or the kind of systems that you're building. Doing some security requirements gathering. What are the important choices to make it for our application, and how best to go about implementing them. Secure design, threat modeling. Some of these make sense at like a larger scale, and some of them you can do at a smaller scale. Threat modeling is something you can spend a couple of hours on identifying where in your system you're most vulnerable, using that to identify where to actually spend your effort if you're going to go to lower level, implementation level steps, like code analysis or penetration testing or fuzzing. Fix the identified bugs. This seems obvious, but for some reason this is incredibly difficult for even very sophisticated environments to get around to implementing. It's difficult to look at a set of bugs of any sort, not just security bugs, and say, okay, these are the high priority ones, these are the low priority ones, we'll get around to these mediums and lows, maybe never. But it's important to take the work that you've done and actually use it to make the code more secure, and then take that learning and feed it back into the process when you go back to do design or develop new features or incorporate customer feedback. Improve the code quality and architecture to reduce the number of vulnerabilities. One of the things that's most important to do is to evaluate, do I have everything happening in the same place? And is there an opportunity to compartmentalize the system or isolate components that are doing something sensitive from things that are doing something dangerous? So for example, if you're doing a lot of parsing in one component of your app, is it in the same component that's doing key management or handling financial transactions or managing sensitive data, writing to the database? Can I isolate those components? They happen in different processes. Can I isolate those components? They maybe happen on completely different systems. And then maybe establish a small channel for them to communicate, whether that's an API or it's a connection between these systems, and reduce the attack surface down to something that's very minimal, so that a compromise over here now requires a compromise in a space that has become smaller and smaller and smaller. Can I get rid of code that is no longer in use? And if it's not in use, maybe it's just providing risk to the business. Can I get rid of it? Is this a feature that we thought we were going to build up and we just haven't gotten rid of it altogether, but it's not in use by our customers? That's all code that's providing risk, and it might not be providing business value anymore. So get rid of it. And then another technique I think is not deployed as widely as it should be, is to reduce the value of the data that you're storing in your environment, because compromise is inevitable. At some point, you might be compromised, and you might be able to identify that it happened, and you might not be, and that's just a factor of how good we are at looking for it. But we always have to behave as though that's the case. So if you are going to be compromised and you're going to create a defensive plan to address that, what does that mean? Okay, maybe the assets we're storing, we actually don't need to. We have a lot of valuable things sitting around that maybe we don't need to keep around anymore. When I leave my car, not only do I lock my doors, but I also take my backpack with my laptop with me. I don't leave cash lying on the dashboard. Someone breaks into my car, they're not going to get to all of my assets. So what this means in the data space is that if I've collected a bunch of information that I don't actually need, doesn't suit my business's needs, maybe I can get rid of it. I'm a messaging server. How long do I keep messages lying around for? How long do our customers need them? Do I have these ideas that maybe someday I'll be able to apply machine learning to it and use it to expand these great new features? If I don't actually have a business need for it today, then keeping it around is a risk to the business. So reducing the amount of data that I'm storing is actually helping secure the business without requiring any new security development. So there are a lot of things that every development environment of any size and any level of sophistication in security in their security organization can implement that will reduce the risk to your customers and to your environment. Thank you.
Thanks very much, Window. I've got a couple of questions, but if the audience wants to think about questions to put to our panelists afterwards, that would be great. So I'll start with asking, is there something you should do as a development community to make open source and widely deployed dependencies more secure? So Chris, can you?
Yeah, sure. So I think we all woke up to how bad this problem was with Heartbleed, which was a critical vulnerability in an open source project called, was it OpenSSL?
Yeah.
And it was a project that had been around for like 15 years. And it turned out that there was only like 2 people working on the project. They were very underfunded. They didn't have the resources to properly do code reviews and proper testing. And this was something that so many huge organizations were relying on. Think of how much code at places like Google and Facebook and probably even Apple was built on top of OpenSSL. These big companies were relying on it, and they all had to scramble and try to protect their customers from this problem. And so the Critical Infrastructure Initiative was started by Google and Facebook and some other companies, I don't know them all, to try to raise some funding to fund some of the critical projects out there. Make sure that they can have proper testing, proper development, proper code review. But you know, there's just so much going on in the open source space. I think that can only touch the most critical things out there. So I think we need to figure out how to get some more tools and free infrastructure that can be part of the automated process that these open source teams use to develop their code, and figure out how to get it to them. So I don't have a good answer, but as a community, I think we need to get behind helping open source developers be more secure.
Okay. Window?
Absolutely. Those kinds of events, though, where a component that is widely deployed, widely in use, and used in a critical systems, at the same time has a vulnerability that is widely known before it's able to be patched. Those kinds of events don't happen very often. They do happen, and when they do, we're all kind of in the same boat, scrambling. And that's very frustrating. But that doesn't happen very often. It's more common that vulnerabilities are identified. A vendor is notified. The open source team is notified. They get a chance to fix it. They issue an update. We get a chance to deploy the patches before folks are actively out there exploiting the vulnerability. So on our side, things that we can do include making sure that we've got a plan to deploy those patches as soon as they're available, because the window of opportunity for the attacker usually looks like the vendor has disclosed the vulnerability because there's a patch available. They want to make sure that you understand how serious this issue is, so they describe the vulnerability. The information is able to be used by attackers and also by defenders alike to either take advantage of the problem or use it to determine where should I put this in my list of priorities to get this patched? So if you can reduce the amount of time it takes to get your patch deployed, then you've reduced the opportunity for the attacker quite dramatically. So even though occasionally we have these events where you've got a critical component that is widely deployed, that has a vulnerability that is widely known, and proof of concept code is available before a patch is widely available, that doesn't happen very often. So for the normal scenario, or the more common scenario, we actually have a lot of things that we can do, including making sure that we are able to quickly deploy critical patches and reduce the window of risk for our environments.
Okay, thanks a lot. I was going to ask just quickly, are regulatory issues now becoming more important for your industry? Chris?
I think so. I think what we're seeing is, the tech industry has largely been completely unregulated, right? People building software, people running systems, and that's been awesome for innovation. And but we're seeing a change now with the way that software is being used, the way we're using it in our everyday lives, the way we're starting to use it with IoT, that things like that used to be privacy issues and confidentiality issues are becoming real safety issues. They could be personal safety issues where people can track you, that want to track you, or they can be physical safety issues where you're operating a device that's IoT, like a car, medical devices. And so I think we're starting to see this point where technology is becoming more dangerous, right? That was kind of a big theme that I saw in some of the talks, that around people manipulating systems. This feels a little bit more dangerous now than it has in the past. And at some point, especially where physical safety is part of it, I think we're really going to have some sort of regulation. And there's some things happening in the U.S. Congress around Internet of Things devices, just to put in some really basic baseline security. Things like the device has to be patchable, right? There are actually devices out there that couldn't be patched that when they were compromised and put into a botnet, the Mirai botnet a couple of years ago. Devices can't have a hard-coded backdoor password in them that can be reverse engineered, and then attackers can get there. So really base level stuff. We're not talking about really sophisticated security here. And I think that's where the regulations need to start. We need some basic safe, for devices that could cause sort of physical harm, we need some basic safety regulations.
What do you think?
So for medical devices and for cars, those devices are already regulated. So I think expanding that regulation to cover the technology aspect in cars and in medical devices that could compromise human safety, we've already got channels for that, and we should work within those channels. In terms of security more broadly in the industry, I think the place I would like to see us devote energy is less to regulation and finding ways for us to create captive markets for vendors to build businesses on new requirements. Instead, provide guidance and tools and methodology and ways for us as an industry to help ourselves, because the individual business requirements for each environment, software deployment, are going to be different. So while it's great to say things like don't include hard-coded passwords, encrypt this communication, that's great for guidance. And then for within platforms saying, okay, if you want to be on our platform, then all your communication needs to be encrypted. That's a reasonable thing for that platform to insist on. And great guidance to give in general, but I don't want to see it regulated by our governments.
Can I just follow up there for a second? Because I think one of the issues is, you can think about the risk that these devices are causing to your life or your business is getting from these software, and make a decision for yourself, or your business can make a decision about how you do risk. But what's happening with IoT devices, we're going to see proliferation of billions of devices on the network. Think about billions and billions of devices that are insecure, like maybe 100 in each person's home. And if those can be compromised, then we have an ecosystem problem where we can't trust anything on the network because there's all these places people can connect through and hide their identity, and they can cause denial of service attacks. So it's really, to me, it's somewhat of an ecosystem problem where, I don't want someone else to have a dangerous device because it could impact me. Like, part of the reasons cars are regulated isn't so that it's the safety of the car owner, it's the safety of the other people on the road, because if you have bad brakes, it could impact someone else. And I think there's a little bit of an ecosystem problem that is starting to crop up with IoT and some other technology.
IoT doesn't actually make the environment any different. Those devices are still computers, just like we already have. They are running operating systems that are, let's say, varied as they've always been. And creating more regulation to address these that goes beyond, let's say, the regulations that we have set up for different industries already. Automotive, great example. Medical, another fantastic example. We've got channels to address those. So I don't think we need to create new ones and potentially stifle innovation. I think guidance is sufficient to our industry and making tools available so folks can leverage this in their own environments and work to make the entire internet more secure.
Okay. Does anyone have any questions from the audience on this kind of issue? No questions. All right. We've got, well, keep thinking if you want. I got one question, another question here is, can we dream of a world where is a cyber attack inevitable, or can they be completely stopped? Can that ever happen?
So it's always a possibility. If there's something valuable out there, and there's somebody who wants access to it, when it comes to systems protected by software, there is so much opportunity to undermine those security systems, because it might be in the code that you wrote. It might be in the libraries that you incorporate, as you brought up. It might be in all the technologies you depend on. It might be in your content management server. It might be in your database. It might be in your encryption library. It might be on your operating system. And if it's not in your operating system, then it's probably in your firmware. And if it's not in your firmware, it might actually be in your hardware. There's so much attack surface that you can't ever say for sure that we've eliminated vulnerability. And even if you have eliminated vulnerability, which good luck with that, if you have, there's always the possibility for someone to incorporate something intentionally malicious into your supply chain. So where did your hardware come from? Is this firmware, the firmware that it's actually supposed to have shipped with? Has it received an update? Is that update in some way checked that it's actually the update that you're expecting and not an update from a third party, a malicious third party? Has it been tampered with since you last saw it? For all the binaries on your system, are all of them validated by the operating system? Is the operating system update validated? There's just kind of so many places for an attacker to identify a problem and leverage it that we can't say that we're ever completely secure. We can reduce our risk. There are a lot of things that we can do, and the industry as a whole is getting better and better at it. But we will never be completely secure. We can just be better at it, and better at identifying problems, better at recovering quickly when there is a problem, and better getting back to a known good state.
Okay, thanks. Chris?
Yeah, I agree that there's so many layers of failure that have to be secured. You can't make a system completely secured because we keep relying on the other layers, and we have so many interdependencies. And we can look for the areas that are the highest risk and try to lower the risk. But I think what Window finished on here on detection and response is really important. So resilience is really important, because if you can detect that you've been attacked, say there's a zero-day vulnerability that you couldn't find, but someone else found it. If you can detect that you're being attacked because you have some system that gets touched or triggered, there's a canary or something where you can see that attackers are in your system, and you do that very quickly, and you have a really good response mechanism, then it sometimes it won't even matter that you were compromised, because the attackers weren't able to keep your business down or take your valuable data. So the resilience is really how quickly can you respond when you know that the system is being attacked. I mean, take ransomware, for instance, is a great solution to ransomware. It's called backups, right? If you keep your system backed up and you do incremental backups and you do this well, and you can isolate your backups so they're running on a diverse system that maybe doesn't have the same vulnerabilities as the attacker, you can get attacked with ransomware, and you can bring your systems back up rather quickly, because of course you know when you're attacked with ransomware because they tell you they want money. So that's a good example of like, maybe you can't harden your system enough so you can't get ransomware, but as long as you can recover quickly, you know, your usage of that technology in your business, it doesn't really impact it that much.
So as soon as we deploy mitigation like that, then the attacker changes their strategy as well. So this mitigation, backups, a very practical and inexpensive way to defeat ransomware today. Ransomware that, for example, stays in your system for a long time and over time slowly corrupts your backups. Because how often do you go back and validate your backups? That might be the next path for ransomware to take. I hope I'm not giving folks new ideas, but corrupting backups over time so that your backups are no longer valid, that would be a reasonable response for an attacker who's trying to deploy ransomware. So we need to continuously, as an industry, a security industry, identify what their next step is going to be and what mitigations we can deploy against the next level attack.
I mean, with ransomware and WannaCry, I've talked to a number of people who say that this stuff is getting extremely sophisticated. Is your sense or fear that, you know, they're just getting better and better, they're getting better at developing these things? What's on these kind of big attacks like WannaCry?
They're getting better, but so are we. So developing those methodologies that go to that next level is critical, which is why I worry about things like stifling innovation. I worry about things like regulations that try to, let's say, limit the availability of dual-purpose tools that might be used for exploit development for defensive purposes and exploit development for offensive purposes. Those kinds of things prevent us as an industry from getting better, and we have to stay ahead of these sorts of attackers. So there are attackers out there with different levels of sophistication. Mitigating, let's say, the bozos and then organized crime and you know, some of those next level attackers, we can do a lot to mitigate those kinds of threats. And for the most sophisticated attackers who can be opportunistic, who can sit around and wait for an opportunity like Cloudbleed or Heartbleed to come along and take advantage of a widespread critical vulnerability that impacts everybody where there's no patch available, those things will happen over time, but that's not going to be every attacker out there. So yeah, we need to be able to stay on top of, a step ahead of the, let's say, the more widespread attacks.
Yeah, Chris, any?
Yeah, the thing that worries me is it seems like the attackers learn quicker from other attackers and have better ways of watching what's working and then incrementally improving on that. Then defenders are able to do that in a widespread way. Of course, there are some defenders that are really good at looking at attacks and doing that, but as a whole, it seems like we don't learn as quickly, or we just don't do anything or realize we should do anything. I mean, from WannaCry, there was a follow-up ransomware called Petya or not Petya, whatever you like to call it, that was only like a couple months later, that was actually more devastating than the WannaCry attack, and essentially it was the same. It had the same vulnerability it exploited, something called Eternal Blue in Windows, but they added in additional vectors of basically compromising credentials, stored credentials on the machines once they were compromised, and using those stored credentials to then attack other machines. So those other machines didn't necessarily have to be vulnerable to the Eternal Blue exploit to get attacked. You just had to have one. So this was, they basically innovated and they said, hey, we can make this attack better than just using the Eternal Blue exploit. And it turned out that both of those techniques are pretty well known. We've seen attacks for both of those techniques, and there was large organizations, big sophisticated organizations like Maersk and Merck and Federal Express that didn't have the right mitigations in place, even though this was well known. So it's a challenge just thinking about it on sort of like they're getting better at knowing what to do. it's a challenge for these big organizations to actually take action even when we know what to do. And that taking action seems like one of the big struggles that, that we have as defenders.
So one of the ways that we're making huge progress, and I agree with you, that's from a deployment perspective, it's difficult to make incremental improvements on defending against those kinds of attacks. But as an industry, we can take something like memory corruption, and we've got two things kind of happening at once, where we've got all these kernel-level mitigations that address stack protections and heap protections and make it more and more difficult to take advantage of memory corruption issues. And at the same time, we've got all of you folks building on higher-level languages where all the memory management is completely abstracted away from the developer. So we don't have use after freeze, and we don't have stack overflows unless they're present in the underlying platform. So if you're writing in Ruby or Java or JavaScript, all those things are completely non-issues for developers today. And over time, we're going to make those even more and more difficult because the attack surface gets smaller and smaller. It's just in the platform now. It's just in the underlying operating system. And it's not in your app necessarily because you wrote it in a higher level language. So the set of things that we need to defend against get smaller because we have provided a broad mitigation that eliminates the entire category of vulnerability or reduces it to a very manageable set. So there are ways that we're going to make it harder in leaps. So it's not about defeating malware necessarily. It's about reducing the ways that malware can get on your system. So 85% of malware gets on your system because you installed it, trying to do something else. And you're like, oh, update your whatever, it's out of date. Fantastic, I'll follow this link, download that package, and install it. Well, now your operating tells you things like, oh, it's not signed, or it's not signed by a developer that we're expecting. And you have to jump through hoops to actually get that installed. And that's not the normal installation process, and that starts to look like a bad idea. So maybe you don't do that anymore. Or maybe you've got a device, like iOS, where you can't actually install something unless it came through a single vector, like the App Store. And whether that's your ideal from a availability of software perspective, or your ideal from, say, a security management of an enterprise or organization, it does reduce the ways that malware can get onto your system. So as an industry, we are still finding other ways to address this that are not necessarily things like protecting the specific vector that this malware might traverse your network and find other vulnerable systems.
Okay, thanks very much. We have to wrap it up over there now. There was one nice little phrase I picked up in the speeches, which was simply software rots over time. So thanks very much, Chris and Window, and see you next year.
Thanks.
Thanks.